So I'll show you by introducing to you an inequality that says A over B is greater than C. Now, if we were to solve for that inequality, okay, depending on what we have to solve for, I know a lot of you will start off by multiplying both sides by B and then obtain A is greater than BC. I know a lot of you would start off by doing that, but please note, guys, you cannot do this. This is incorrect. You cannot do this. Why? Because you cannot say that B is a positive number. B could be a negative number. So let's say if B is a negative number. If it is negative and we multiply it onto both sides, remember, if we multiply or divide by a negative, we must switch the sign. Do you remember that? If it's a negative, the sign would have to switch, but we cannot see if B is negative or not. So we cannot go like this straight away. Okay, so I'll rub this off because it's incorrect. And I'll show you a different way to solve those kind of inequalities in a more accurate way. Now what I'm going to do is multiply both sides by not B, but B squared. Because we all know that B squared, anything squared, is going to be positive, isn't it? So if I multiply a positive number B squared onto both sides, that is still possible, isn't it? That's definitely okay to do. So I'm going to go for that, as B squared is definitely positive. So that leads me to cancel out these B's. So on this side I have A times B, AB, it's greater than, the sign remains unchanged. And then in this side we simply have B squared C. And that's basically it. Okay, so the key thing here is to not multiply just by the denominator, whatever the denominator is, in this case B, but please multiply by the denominator squared onto both sides, of course. Okay, so please remember that. And I'll show you how to apply those into some questions. So have a look and let's try some questions now. Starting with question 1. Okay, this question says solve 1 over x is greater than 2. Now we've got a fraction similar to that form A over B is greater than C, isn't it? So what I'm going to do, please guys, don't say that we're going to multiply both sides by x, but we're going to multiply both sides by x squared, okay? Because in that case, we know that x squared is definitely positive, that's definitely applicable. So let's simplify. We'll have x on this side because I can cancel the squared and that x, so we'll have just x left, and this side we have 2x squared. Okay, now what I'm going to do is I'm going to move everything onto one side. Okay, so basically I moved x onto the other side and then just put the inequality over here. Okay, for those who are confused, I'll just do this for you really quickly. It's going to be 0 on this side, minus 1, and then I just switch those two around, so I have this order. Okay, so 2x squared minus x is less than 0. What I'm going to do is factorize by x, which is the common factor, x. So I have x, and then inside the bracket I have 2x minus 1. Simple factorizing, and that's still less than 0. Okay? Now, when I get to this step, I always like to do a parabola. I just want to draw a really brief parabola because that always leads me to the correct answer. I'll show you how. I'm just going to draw a really brief looking parabola. Here, x is going to be 0. Here, x will be a half if I let this whole thing be equal to 0, isn't it? Therefore, the intercepts will be 0 and a half, but because it's less than 0, it must be below the x-axis, so it must be here. What kind of inequality would describe that kind of parabola or that kind of region? It would definitely be this one. X is between 0 and a half. Okay, between 0 and a half, that's my solution. Okay, so have a look. And that's the answer to the question. Okay, so it's actually quite simple. Alright, that's question 1. Have a look. And let's move on and try another question. Question 2. This question says solve 2 over x minus 3 is less than 1. Now I know this time the denominator looks a little bit more bigger or longer, but we're still going to treat it the same way. Okay, so I'm going to start off by doing the denominator squared onto both sides. So see how I multiplied x minus 3 squared onto both sides like this? And then I can simply cancel this one, and I'll simplify like this. 2x minus 3 is less than x minus 3 squared, okay? Now, one thing I don't want you guys to do is cancel this out. Please don't do that. You cannot cancel out pronumerals, all right? So please don't do any cancelling from here. We're going to start moving everything onto one side like this. So I'm basically moving this onto this side, okay? This one goes onto the other side, so I have x minus 3 squared minus 2x minus 3. Now, I know a lot of you will start expanding in this step. Please don't do that. You can expand it and then simplify it and do it that way, but that's going to cause a lot of silly mistakes, especially when the question gets a lot more bigger or more complicated. So please don't expand. Follow my steps. Move everything onto one side and try to factorize that way. Okay, so I'll show you. Now that I've moved this over to this side, can you see that x minus 3 is a common factor? So I'll just factorize by x minus 3, just like this. So I took x minus 3 out, therefore here I'll just have x minus 3 left, and here I'll have minus 2. Okay, so I just factorize like that. Simplify, you'll have something like this, because x minus 3 minus 2 is x minus 5, isn't it? That's how I simplified it, so it's much easier without the expansion. So now I've got to this step, I'm going to start drawing my parabola, which I always like to do. Draw a brief parabola. Doesn't have to be too accurate. And you can see that here, x-intercepts will be 3 and 5, right? So I'll put 3 and 5. Now this time it's greater than 0, so it must be above the x-axis. So it will be on these regions. Okay, because it's above, it must be on this and this side of the parabola. So therefore, my final solution, as I look at the parabola, will be this one. X is greater than 5. See how it's this region is x is greater than 5. And for this region, x is less than 3. Okay, because it's talking about the regions on the left-hand side. Okay, that's basically it. So as long as you draw the parabola correctly, the answer should be easy to find. Okay, so have a look. I hope you've realized that drawing a parabola does really help. Okay, so have a look. And that's basically the solution for question 2. So we did a very similar pattern to question 1, haven't we? So have a look and let's move on to question 3. Question 3 says solve 2x plus 1 over x minus 2 is greater than 1. Okay, now it's getting a little bit more complicated, but it's actually not, because we're still going to be just treating it the same way as we did for question 1 and 2. So we're going to do our usual thing, multiply the denominator square onto both sides, just like that. Okay, so x minus 2 is the denominator, just multiply the square of it to both sides. So now I can just start cancelling like that, right? And just simplify like this. So this side I have 2x plus 1 and x minus 2, and this side I just have x minus 2 squared. Okay? Now again, please don't just expand. Please don't expand. That's going to be very, very confusing and lead you to silly mistakes. So let's move everything onto one side like this. So this one, I just moved it all over to the left-hand side. So I have all this 2x plus 1, x minus 2 minus x minus 2 squared, and that's greater than 0, isn't it? So now that I've got that, let's look for common factors. Hope you guys can see that x minus 2 is a common factor. So let's factorize by x minus 2, like this. So I took x minus 2 out, so we have 2x plus 1 over here left, and here we have x minus 2 left. Okay, and of course that must be a minus. Let's simplify inside this bracket, like this. This one, I'll just write over here for you. That will be 2x plus 1 minus x plus 2, because a minus minus makes positive. So 2x minus x is just 1x, and 1 plus 2 is 3. Okay, just simple algebra. And x minus 2, x plus 3 is greater than 0. This is where I draw my parabola. Just draw a brief looking parabola like that. And hope you guys can see the x-intercepts will be 2 and minus 3, isn't it? So it will be minus 3 here and 2 is greater than 0, so above the x-axis. So the regions will be over here and here. Okay, so we need to know the inequality that describes this part and this part. So what are the solutions? Just like that. X is less than -3, this part, and for this part, x is greater than 2. Okay, and that's basically it. So have a look. So it's a very similar pattern. Hopefully you're getting the hang of this now, even if we did just 3 questions. Okay, so hope that's clear. Have a good look at that, and let's move on. Okay, so question 4 says, solve x squared minus 4x plus 3 over x plus 2 is less than or equal to 0. Okay, it's a little bit more complex, but still apply the same method. So I'll multiply x plus 2 squared onto both sides, the denominator squared. Okay, and in that case I can just cancel like that, and our simplified form will just be something like this. So on this side we have x squared minus 4x plus 3 times x plus 2, and 0 times whatever is just 0, isn't it? So that's what I've simplified down to. Now guys, see if you can factorize any further. This one is a quadratic, so can we factorize this any further? I think we can. I think we can do x minus 1, x minus 3, isn't it? That's how I factorize this quadratic, and of course still add on the x plus 2. So this is where I draw my graph. This time it's not going to be a parabola, since we've got 3 x's, so it's going to be a cubic. So what I'm going to do this time is a positive cubic, since all the x's have a positive sign in front. So it's going to look like this kind of cubic. Now what are the intercepts? We have here, we have 1, here we have 3, here we have minus 2, don't we? So plot them in, just like this. Minus 2, then 1, 3. Make sure you put them in order though. Okay, now I've got that. Okay, check. It's going to be less than or equal to 0, so it must be below the x-axis. Okay, so it must be over here or here. Okay, so there are again 2 different regions. So I'll just rub this off and just show you what my inequalities will be. It will be x is less than -2, or x is between 1 and 3. But guys, have a look at the answer. See how here we have greater or equal to, or sorry, less than or equal to here and greater than or equal to here. But see how we only have a less than here? Why don't we have the equal to sign, whereas we have the equal to signs here? Look back to the original question. Look at what the denominator is. Denominator is x plus 2. Look, if x is -2, we'll have -2 plus 2, which is 0. Can we have 0 on the denominator? No, definitely not. Okay, hope you remember that I said that we cannot have denominator as 0. That will be undefined. So always check when you got these kind of questions, we cannot have equal to -2 here, because that will make the denominator 0. Okay, so always watch out with the equal to sign. Okay, so that's our final answer. If you do put the equal to sign, you do lose quite a few marks. So have a look, and also have a look at the cubic. It's going to be different to the parabola. And that's our answer for question 4. Okay, let's look at question 5 now. Question 5 says, solve x squared minus 4 over 3 minus x is less than or equal to 0. So again, I hope you guys can see this time it's equal to again, so make sure we'll watch out for that at the end. So we'll do our usual thing there at the beginning by multiplying the denominator squared onto both sides. So I'll go 3 minus x squared onto both sides, and then I can just cancel this. So hopefully these steps are very familiar for you now. Okay, so what do we have left? Just this. We have x squared minus 4, 3 minus x, yeah? And that's less than or equal to 0, since 0 times anything is 0. That's what I have. Now guys, again, see if we can factorize any further. x squared minus 4, that's another quadratic, so can we factorize that? It's a square minus a square, so we can factorize that by going x plus 2, x minus 2, and of course add the 3 minus x, okay? Multiply the 3 minus x. That's less than or equal to 0. Now, have a look, guys. The thing I want you to remember is these kind of ones, 3 minus x. If I rearrange this one, that actually is negative x plus 3, isn't it? If I really don't like to have a negative in front of my x because that will make a negative graph. So what I'll do is factorize this by negative, okay, or negative 1 if you like to be specific. Negative, that will become a positive x, that will become a negative 3, isn't it? So if I do factorize this one, okay, if I change that into something that looks like this, and then because this side is 0, I'll divide both sides, or you can think of it as multiplying both sides with negative 1, okay? Remember, if I divide or multiply by a negative number, we switch the sign. So what I'll have is something like this. I'll have x plus 2, x minus 2, and then I'll have x minus 3, but because we multiplied or divided by the negative sign, or negative 1, we're going to flip the sign, okay? And this side still remains a 0 because 0 times anything is just 0. Okay, so hope you understand what I did there. Okay, I really don't like to have a negative in front of that because it makes it confusing. Okay, so have a look, make sure you switch the sign, and let's do our usual thing now. Okay, so now we're at the stage of drawing our graph. Again, it's not going to be a parabola, it's going to be a cubic, isn't it? Because we've got 3 x's. So let's draw our cubic. It's going to be a positive cubic, which goes upwards on our right hand side, since all the x are positive signs in front now. And what are the intercepts? Here will be negative 2, here will be positive 2, here will be positive 3. Okay, so put them in order, negative 2, 2, and 3. Okay, it's greater or equal to 0, so it must be above the x-axis, so it must be over here or here, right? So think about it, guys. If you have a look at that kind of graph, what will the inequalities be that will demonstrate those two regions? Think about it. Okay, let's put it in. It's going to be between negative 2 and 2, so x is greater or equal to negative 2 but less than or equal to 2, or x is greater than 3. Okay, greater or equal to 3. Now guys, can we keep all those equal to signs? No. Have a look at this one. We cannot have equals to sign here because if x equals to 3, here on the denominator we'll have 3 minus 3, which will make a 0. We cannot have 0 on the denominator, so we're going to simplify this to, we're going to keep this one the same, but this one we're going to have just x is greater than 3, not greater or equal to, since x cannot be 3, because that will make the denominator 0. Okay, so after you put that step, you may like to just delete that bar, okay, to represent the final solution. Okay, so again, make sure you always check back to the original question. Alright, so have a look. Okay, so again, that was question 5, a very similar pattern. Let's do the next question. Question 6, we've got x minus 4 is less than 5 on x. What's the denominator this time? It's going to be x, so we'll do our usual thing. Multiply both sides by x squared. So here we can cancel the square and the x, so we'll simplify down to, here I'm just going to expand it out, okay, because this is just x, so it's not going to make a difference. So I'm going to go x cubed minus 4 times x squared is less than 5x. Okay? And let's move everything onto one side like this. Okay, that's less than 0, so I just simply move the 5x onto the other side. And guys, can you see a common factor? Can we factorize? Yes. X is a common factor, so let's factorize everything by x. So we'll have x squared minus 4x minus 5. Okay, and that's less than 0. Okay. Now, can we factorize this quadratic any further? I think we can. I think we can go x plus 1, x minus 5, can't we? Okay, simply just factorize the quadratic. So I have x plus 1, x minus 5 is less than 0. Okay, so we've completely factorized it. Let's go ahead and draw our graph. So again, hope you guys can see it's not going to be a parabola. It's going to be a cubic again because we've got three x's. Okay, not different x's, three x's. So again, draw my cubic. Here it's going to be 0 minus 1, 5. Okay, so let's put them in order. Minus 1, 0, 5. Okay, it's less than 0, so below the x-axis. So it must be over here or here. Okay, that's what my regions are going to be. Let's find out inequalities that make this true. It's going to be x is less than negative 1 or x is between 0 and 5. So that's our final solution. And we don't even need to worry about looking back into the original question because it does not have the equal to sign. So we don't even have to worry about it. Okay, that's our final solution. So have a look. So hopefully you can realize now that majority of these questions are very similar. Okay, it's kept the same pattern. So I hope you're getting the hang of it now. That's question 6. Let's move on. Okay, question 7 says find all positive values of x for which 6 over x is greater than x minus 1. Okay, so it's basically asking us to do the same thing as the previous questions, just solve for x, but it's asking us to find the positive values of x. But we'll worry about that later when we get to the final solution. I'll show you how to approach that kind of aspect later when we get there. So first of all, let's just keep our usual pattern by multiplying the denominator squared onto both sides, just like this. So see how the denominator is x? Just multiply x squared onto both sides. So we have this, so we can cancel that out, and we just have 6x is greater than x minus 1 times x squared. Okay, let's simplify by moving everything onto one side like this. Basically, I'm moving the 6x onto this side, so I have minus 6x, and it's going to be less than 0, but I just put the less than 0 onto this side. I just like to keep it on my right hand side. Okay, so now let's factorize. What is the common factor? Hopefully you can say it's x. So x is a common factor. I'm going to factorize by x. I'll have x minus 1, x minus 6 left inside the brackets, and that's going to be all less than 0. Simplified by expanding and simplifying inside the bracket. So I'll have something like this. Basically x times x is x squared, negative 1 times x is negative x, and then minus 6. That's all I did. Okay? Can we factorize this further? I think we can. I think we can factorize that quadratic like this. So I have x plus 2, x minus 3, less than 0. Okay? So hopefully, guys, you can see that it's going to be a cubic because we've got 3 x's. So I'm just going to draw my usual cubic graph like that. What are the intercepts? 0, negative 2, and positive 3, right? So put them in order onto your graph. I've got negative 2, 0, and 3. Okay, and then it's going to be less than 0, so it must be below the x-axis over here and here, right? So that's what I've got. Let's delete this all. Okay, so have a look at the diagram. Let's see which inequalities will hold for these regions to be true. Will definitely be x is less than negative 2 and x is between 0 and 3. So x is greater than 0 and less than 3, right? So I hope you're used to this kind of thing now. Okay, but that's not the final solution. This is where we're going to look at the positive values of x. It's asking us to find the positive values of x. Have a look. X is less than negative 2. Negative 2 is a negative number. If it's less than negative 2, it will be even more negative, isn't it? So therefore, that does not satisfy what the question asks us to find, is it? So that's definitely not going to be it. Now have a look at this. X is between 0 and 3. Well, if it's between 0 and 3, it must be positive. So therefore, the only solution will be x is greater than 0 and less than 3. That's the only solution. Okay? But it's important for you to actually write this down and then show that you've eliminated it and only got to this solution. Okay, so just be smart to show your teachers. Okay, so please don't forget the last step. I don't want you to miss any single mark. Okay, so that's the only difference. So have a look. That's question 7. So hopefully it wasn't too difficult. Let's move on to question 8. Find the solution set for 1 over x minus 1 minus 2 over x is greater than 0. Okay, we've got two different fractions here. So what are we going to do? It's a bit of a unique question, isn't it? We've got two different fractions. So I'll show you my first step. I'm going to multiply the denominator squared onto both sides, but we've got two denominators, so I'm going to do both of the denominators squared. Okay, so I'm going to do x minus 1 squared and x squared onto both sides. Okay, so basically I have to multiply it to all these terms. So I've multiplied x minus 1 squared, x squared onto this one, minus 2 over x, x minus 1 squared, x squared onto this one, and 0 times anything will just be 0, right? So I've got that. So if you can see, we can start cancelling again. Cancel that, cancel that. Okay, so what do we have left? We have x minus 1, x squared, minus 2, x, and x minus 1 squared is greater than 0. And now we don't have any more fractions. I think it will be a little bit more easier to work with, isn't it? Yeah? So guys, this is the thing. If you see more than one fraction, still the denominator, we cannot guarantee that that's going to be a positive number. So make sure you always, if there's like 5 fractions, still multiply 5 of those denominators squared onto both sides. Okay, so that's the thing. That's what I did here. So now that I've got to simplified form this one, okay, let's factorize like this. Because x and x minus 1 is a common factor, isn't it? So I've factorized by x, x minus 1. So if I do that, what do I have left here? Just x minus 2, x minus 1. Okay, just factorizing it. And that's still going to be greater than 0. Let's simplify it like this. So over here in this big bracket, I'll have x minus 2x plus 1, isn't it? Okay, I'll just write that for you so you don't get lost. X minus 2x plus 2, because negative negative makes a positive, so I have plus 2. So x minus 2x is minus x, and then plus 2. Okay, that's greater than 0. Now, hopefully you guys know that I don't like having negative there. So this one, I can factorize by negative and go positive x minus 2, right? So, hope you guys can see that if I divide both sides by a negative, I won't have any negative here, but I'll have to switch the sign. Okay, if I'm dividing or multiplying by a negative, I always switch the sign. And then 0 divided or multiplied by anything is just still going to be 0. That's what I have. Okay, so I hope this step is not too difficult for you guys. So we've got to that step. Let's start doing our cubic, because it's got 3 x's. So draw your cubic. What are the intercepts? It's going to be 0, 1, and 2. So put them in 0, 1, and 2. It's less than 0, so it must be over here and here, isn't it? Okay, so hopefully from now on it's really simple. Just cancel that. So what are the inequalities? It will simply be x is less than 0 or x is between 1 and 2. So x is greater than 1 and less than 2. Both of them satisfy this region, okay? Because there's no restrictions for this question, so that's our final solution, okay? But do always check back to the original question to check if you've actually answered the question, okay? So that's basically it. It's actually pretty simple. Solve this up. So the key thing here was to multiply all of the denominators squared onto both sides, okay? So don't forget that one. That's question 8. Let's move on to question 9. It says find the set of values of x for which x over x minus 2 over x plus 3 is greater than a half. Now I know there's 2 fractions, but guys, we all know that 2 is a positive number, right? 2, positive 2, that's a positive number, so we don't have to do 2 squared here, okay? So don't get mixed up with that. So what I'm going to do is just multiply by 2, not squared, just 2, because I still want to eliminate the denominator. So I'm going to multiply by 2, and then of course denominator squared, x plus 3 squared, onto both sides, okay? So hope you know why I'm multiplying by just 2. Just want to eliminate that fraction, that's all. Okay, so what do I have? I can cancel this one, and I can 2. I can cancel. Okay, so see how I've eliminated that fraction now? That's why I multiplied by 2. So what do I have left? I simply have 2x, x minus 2, x plus 3, and on this side I just have x plus 3 squared. Okay, so have a look. And let's move everything onto one side, just like this. So I'm basically moving x plus 3 squared onto the other side. So I have minus x plus 3 squared. Common factors, it's going to be x plus 3. X plus 3 is the common factor, so I've factorized by x plus 3. We'll have 2x, x minus 2 left over here, and x plus 3 left over here. Okay, let's put that all in the big bracket. We're going to simplify that in the next step, like this. So basically, I'll just show you how I got to that. It's just some simple algebra. I'll just do it. 2x squared minus 4x minus x minus 3. Okay, that's basically it. Now 2x squared goes out the front, minus 4x minus x is minus 5x, and then minus 3. That's how I simplify to something like that. Okay, that's all greater than 0. Now guys, see if you can factorize this. I think you can, like this. That will probably be 2x plus 1, x minus 3, right? So I'm not going to go to how I factorize that. Probably you might have to use the cross method if you know what that is. Okay, but I'm not going to go through how I factorized it, but I hope you guys all understand. It's going to be 2x plus 1, x minus 3, times x plus 3. That's all greater than 0. Now that I've got to that point, I'm going to do my graph. It's going to be a cubic again, like this. So what are the intercepts? It's going to be negative 3, here, negative a half, and here, positive 3. So put them in order. It's going to be negative 3, negative a half, and 3. Greater than 0, so it must be above the x-axis, so over here and here. Okay, so that's how I got my regions. So after I look at my diagram, what will be the inequalities that hold these regions? It will simply be x is between negative 3 and a half, negative half, so x is greater than negative 3 or less than negative a half, or x is simply greater than 3. That's the final solution. Okay, so have a look. And I hope you realize that for every question that we've done so far, it's basically the same method, isn't it? So as long as you remember the denominator squared onto both sides, you've got no problem. That's the key thing to this section. Okay, so that was question 9.